video I'm going to show you how to do AQA A-Level Maths, June 2018, Paper 2, question 14. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition both online and in person. I live in Buckinghamshire, England. A quadrilateral has four vertices, A, B, C, D, with the position vectors given. Write down the vector AB. So if you think about the quadrilateral, there are various vertices, for example, A and B. Each of them we are given their position relative to the origin. So OA would be that sort of vector starting from O to A, and OB would be this sort of vector, and we want to find AB. So if you look at the diagram here, to find AB, we would go from A to B, which means going backwards along A, OA, or minus OA, and plus OB. So AB is OB minus OA. So it will be minus 1 to 7, minus 3, 5, 1. And if we work that out, minus 1 minus 3 is minus 4, 2 minus 5 is minus 3, 7 minus 1 is 6. And that completes part A of the question. Part B, show that ABCD is a parallelogram, not a rhombus. So again, if we imagine the 4 points, maybe A, B, C, D, what we would expect if it is a parallelogram or a rhombus, we would expect the opposite sides here to be equal. So AB would equal DC and BC would equal AD. If it was a rhombus, all the sides will also be equal length. If it's a parallelogram, the opposite sides will be equal length, and these opposite sides will be equal length, but the adjacent sides will be different lengths. So we need to work out each of these vectors. We've already got AB. We could work out each of the others. So BC, using the same method as we used in part A of the question, will be OC minus OB. So it'll be 0, 7, 6 minus 1 to 7. So 0 minus 1, it'd be 1. 7 minus 2 would be 5. 6 minus 7 is minus 1. We've also got DC, which will be C minus D. So it will be 0, 7, 6 minus 4, 10, 0. Which will give us minus 4, minus 3, 6. And finally, we have got AD. AD will be D minus A, so it will be 4, 10, 0 minus 3, 5, 1, which gives us 1, 5 minus 1, and you can see here that AB is equal to DC, AB is equal to DC, and BC is equal to AD, which tells us opposite sides are parallel and equal length, which tells us it's either a parallelogram or a rhombus. But now we can compare the side lengths. So we use Pythagoras for this. So if we work out the length of AB, it will also be equal to the length of DC, because that's the same vector. And it will be the square root of minus 4 squared plus minus 3 squared plus 6 squared, which is the square root of 61. Likewise, we can work out what BC and AD is. BC, the length of BC and the length of AD is the square root of 1 squared plus 5 squared plus minus 1 squared, which is square root of 27, which we can also write as 3 root 3. So we can see the adjacent sides are unequal length, So together those two facts, 1 and 2, 1 plus 2 tells us it's a parallelogram but not a rhombus. And that concludes question 14.